Alright, screw the intro, let's just get to the point. So, do you guys remember that humanoid robot I was making, which I'd said I'd make a part 2 about when it had arms and could do the housework? Well, let's just say a little something happened.
Shortly after making the video, when I was starting to work on the arms, I came back from school one day and found my robot had gone up in flames. Okay, well, maybe not completely, but some cables were completely incinerated. Specifically, it seemed to have been the ones connecting the batteries to the charging port on its back. And the charger was completely dead and smelled like the time I first tried to power an LED before knowing resistors were a thing. But why? Well, actually, quick context. Just after finishing the video, I began to notice the robot's Raspberry Pis would shut down when the motors drew too much current. And at this point, I'd done some more research and was a bit more aware of the fact that what I had was a cheap Chinese battery pack with a fake capacity label. Packing 30 amp hours into this is physically impossible. And in any case, it was probably not a great idea to have the motors and the Pis fight for a single energy source. So I determined the best solution would be to make my own battery. That way, I'd have full control over its actual capacity.
So I bought my first spot welder and ordered 30 21715 amp lithium-ion cells of 5 amp hours each from an actually reputable seller. I also got a BMS, or Battery Management System board, which is essential to making an actually decent and safe battery. When they arrived, I quickly got the hold of spot welding, wired them into 3 groups of 10 batteries in parallel, wired those groups together in series so their voltage would add up, made a mistake along the way which turned part of a nickel strip into lava for a moment, and ended up with this beautiful 12 volts, 50 amp hour battery which has just the right shape to fit into the bottom of the robot's torso, letting its central bar pass through the middle. Wait, that's better. Now, see the difference? So, as the Pis draw relatively little power at a mostly constant rate, I left the smaller battery to them and connected all my motors to the new one. Now, back to the accident. After researching for a while, I came to the conclusion that it might not have been such a good idea to connect 2 lithium-ion batteries with vastly different capacities to a single adapter not made for lithium-ion battery charging. Because you see, proper chargers use CCCV, where they first output constant current while increasing the voltage, because the battery voltage increases as it gets fuller, and then switch to outputting constant voltage and decreasing current. My charger, on the other hand, just spat out 12 volts all the time.
But anyway, the real problem here seemed to have been that as I was charging both batteries with the same charger, the smaller one reached a higher voltage more quickly, and as it was hard connected to the bigger one, current flowed from one to the other that somehow caused a backflow into the charger, and yeah. Eerily enough, the only reason the batteries didn't literally explode and burn my entire house down was that they both had a BMS on them. So, yeah, really don't try this at home. So, of course, I needed a new setup. With a new charger. Well, new chargers actually, as we really don't want to be connecting both batteries together again. But also, I was starting to realize that the charging station I'd made was, to put it bluntly, a pretty big piece of trash.
It was very flimsy, as it was a very thin 3D print reinforced with pieces of my school's fence and some popsicle sticks. But especially, it was extremely unreliable. After all, the setup consisted of a little connector plugging into a little hole in the robot's back, and the flimsiness of the guides which were supposed to ensure this happened didn't make it better.
So I decided to completely overhaul the charging station, and began investigating to see how they're usually made.
Of course, there are many different systems you can choose from, each with its pros and cons. One that really attracted me was that of the RoboPads, which uses conductive magnets as contacts to ensure a secure connection. However, this would be really expensive even if I decided to make my own, given the materials needed.
So after discarding a magnetism-based setup, I found that the most common approach by far was a spring-loaded one.
This can also come in many forms. For example, the Roomba slides some metal pads on its underside onto these spring-loaded pads on its charging base, while other robots use spring-loaded pins, or pogo pins, which make contact with some pads on their back. Although this isn't as reliable as a magnet, which literally attracts the robot to the correct position, pogo pins come in many different sizes and extension lengths, so they should be able to provide all the margin I needed.
And just when I had the main idea settled, I got a stroke of luck. Except little did I know, it would be the complete opposite. You see, I was contacted by, and I really don't care about protecting any brand image at this point, JLC, a Chinese company that offers services like 3D printing, PCBs and CNCs. And they offered to sponsor one of my videos by providing one of their products for free. And that was great. Now that I wasn't constrained in budget, time or hardware to a stripped down 3D printed structure, I could make my charging station as a single robust print.
So I designed this new, more chunky version of the charging station with 4 holes, one for each of the pogo pins corresponding to the positives and negatives of my 2 chargers, and a matching updated backplate for my robot with slots for 4 metal pads I'd install.
And after I sent them the file for printing, it was as if the universe turned against me. Like, I kid you not, first, the employee in charge of handling my case changed position and they had to assign me a new one. Then, the payment they had arranged so I could pay the customs fees never arrived. Then, I had to resubmit the order because 30 days had passed without it being paid. Then, apparently they would be releasing a new method internally which would avoid the need for me to pay the customs, which also never arrived. Then, the new employee got a cold and was out for more than 2 weeks. Then, they finally gave me a specific release date for the new system, and when the day arrived, it turned out I had to make a new JLC account. Well, fine. Except a freaking typhoon interrupted the process once more. And when we were finally getting back to it, they went on holiday for Golden Week in China. And then she got sick again. But wait, because she finally came back, only to tell me the factory's capacity had recently become limited, so I should wait an unknown amount of time or look for another provider. 3 months and a half. That is how long I waited for absolutely nothing. And the worst part is, that was when my summer holidays ended. So for anyone wondering why it took so long to get any updates on my robot, that was basically what happened. Anyway, at that moment, I decided to take everything into my own hands, like I should have done from the beginning, and looked for a suitable main structure for my charging station in the garbage container.
I found a speaker which looked like it was made of really solid plastic, took it home, and painstakingly cut it open to the right size, while I realized it was actually made of wood. I also ordered some pogo pins, just the longest ones I could find which met my electrical specifications, and when they arrived, I soldered the wires onto them, inserted them into holes placed just like in my original design, and added some angle brackets to the box so I could attach it to my wall. Then I got some metal plates, designed some 3D printed attachments to mimic what I had before, just more robustly, and added them to my charging station. Finally, I bought a proper lithium-ion charger and an even more proper 10 amp charger for the big battery, which I placed inside the box, and connected them to the correct pogo pins. And with that, my new charging station was complete. I then called it a day and started working on the robot's arms, though I'll go into that when I've actually completed that part.
But then, as I decided to test my arm setup by making the robot mop my house, which seemed like a good, simple task to test for basic arm movement, the navigation started to fail miserably. It had so much trouble even leaving the first room and kept getting stuck.
Given the similarities in behavior, I thought it might be lag again, and considered getting another SBC like an Orange Pi, which might give me a better bang for the buck in terms of RAM and CPU power. However, I found out it wasn't actually using up that much RAM, and the percentage of the CPU, which was a bit over 100%, was out of a single core.
Instead, I tried to solve it through parameter tuning and spent a really long time analyzing the ODOM and adjusting, but nothing would fully work. At one point, I even went back to the arms and thought I'd just deal with it later out of desperation. Eventually though, after further examination, I came to the conclusion that it was the rotation which was causing much of the disruption, as the robot found it abnormally hard to turn and therefore deviated significantly from the odom every time it tried to do so.
And so here it appeared it was time to address the elephant in the room, the fact that my wheels were literally bare pieces of plastic. I realized that when the robot turned around itself, the wheels would have to track sideways, which of course made it much harder, and is why it just wouldn't turn at all if I ever attached tires to them. Instead, I determined the best solution would be this really cool looking kind of wheel. These are called omni wheels, and they act like wheels in two axes at the same time thanks to the rollers they have all around them. They're often used for this kind of robot, allowing motors placed at weird and apparently impossible angles to produce correct movement nonetheless. However, they'd also help for my case, since there would basically be no sideways friction.
So I got some of those, attached them to my robot, and the result was underwhelming to say the least. It still found it hard to move, but now especially forwards and backwards, as the wheels were kind of bumpy. Sometimes it wouldn't even start. At this point, it was clear that with the 2 extra kilograms from the battery, the robot had become underpowered.
I first thought of replacing the motors, but then I remembered I was using an L298N driver, which is really simple and fine for basic projects, but has the disadvantage of a 2-volt voltage drop which prevents the motors from getting close to their full potential. I'd used it because it was what Ro's Arduino bridge, the package I was using since I followed Josh Newman's Ro's guides, supported. However, I just said screw this and began modifying the source code to be able to use the TB6612 FNG drivers I'd originally bought before finding they were incompatible. And I managed to make it work. And wow, did that make a difference! It's like the robot had had breakfast for the first time in 5 years. Except, it still couldn't navigate. Turns out I'd set the wheel separation multiplier to 10 back when turning was so hard, and forgot about it, and yeah, it took a while to find out that was the cause. I also made the cost map a bit more permissive along the way to prevent the robot from falsely thinking it was stuck.
So yeah, that's basically what's happened with my robot and why it's still not able to cook me dinner. I just thought you guys should know so you don't repeat my same mistakes. I'll get back to the arms now, although, of course, I don't know how many hurdles I'll have to face, how many times I'll have to go kind of back to square one, or how long it'll take, but you can be sure I'll always bounce back because I freaking love robotics. Thanks for watching, and I'll see you next time.